Alright, in this video I'm going to be working a full practice AP Precalculus exam. And if you're in my class, this is the full mock exam homework, and this is kind of what the front page looks like. So the first section is multiple choice no calculator. And the first one's talking about which of these statements about really the nature of the behavior of f is correct. All right, so 1 to 3 increasing at an increasing rate. No, that doesn't seem right. Okay, from x equals 1 to x equals 3. Okay, the graph of f is decreasing and concave up. So it's decreasing at an increasing rate. Okay, don't think too deep on this. Like, you are going to trick yourself into the wrong answer, right? If f is decreasing, it has a negative rate of change. And if the graph of f is smiling, then f is concave up, which is equivalent to having an increasing rate of change. So it's decreasing at an increasing rate. The slope is less negative. It's closer to 0. It has increased as I move left to right. All right, I think that's enough of that. Decreasing at an increasing rate. This one looks like more of the same. A graph of the polynomial function g is concave down from 0 to 10, which of the following could be a table of functions. All right, well, concave down is going to mean the rate of change is decreasing, and we could see that if we were looking at, tables with evenly spaced x values, if the second differences were all negative. Okay, so up here I am, only say concave down. So 1 to 2, that's going to be plus 1. 2 to 4 is plus 2, 4 to 8 is plus 4, and 8 to 16 is plus 8. Okay, and I'm kind of now recognizing that's an exponential function with exponential growth. That's going to be concave up. Okay, so that one's out. Okay, but we could also see that looking at the second order differences. These are all positive, right? Plus 1, plus 2, plus 4. Okay, then for B, I'm going to do the same thing. I'm going to add 10 here, add 5, add 10, and add 5. Okay, so from adding 10 to adding 5, that's a decrease of 5. Okay, looks like the graph would probably be concave down on that interval. Okay, but then 5 to 10 is an increase of 5, so that's a positive second order difference, which is feeling like concave up. Okay, so it's not concave down the entire time from 0 to 10, because we're seeing x between 1 and 5, where we have a positive second order difference. Alright, so then g of x, I'm looking up here, 1 to 5, that's plus 4, plus 2, minus 2, minus 4. This feels right. Okay, so I'm decreasing by 2, decreasing by 4, decreasing by 2. All three are negative numbers. Yeah, I feel good about that. Okay, what's happening here? Negative 4, negative 2. Yeah, that's increasing by 2. Okay, so that's not necessarily going to be concave down. Alright, there we go. That's number 2. The graph of h is a transform of g, where h is 2g plus 3. Okay, which of the following points is on the graph of h inverse, the inverse of h? Well, I think I'm going to start by knowing the one point that must be on the graph of h, and then I'll think about the graph of h inverse. Alright, so point 3, negative 2 is on the graph of g, so that means that g of 3 equals negative 2. Then I'm going to say h of, I know how to plug in 3, so h of 3 equals 2 times g of 3, which we know is negative 2, then plus 3. So did the work to know that that was going to be negative 2. So 2 times negative 2 is going to be negative 4, plus 3 is going to equal negative 1. Okay, then that tells me that on the graph of h, I've got 3, negative 1. Okay, so that, if you like to do that one thing I don't like, you could just say, okay, it's going to be answer choice A. But if I know that h of 3 equals negative 1, then I know that h inverse of negative 1 is going to equal 3, because it just works in reverse. So that's showing me that answer choice A is definitely going to be right in a way that I like a little better. Okay, so what are all values of x for which natural log of 3x plus natural log of 2 equals 4? Okay, when we have one of these with kind of two different logs, we're going to want to combine them with a log property, because we can't say that e to the this side equals e to the that, and then say it's 3x plus 2 equals 4. That's what they want you to do, and that is not going to be right. That's going to probably give you answer choice A. So we're not going to do that. We're going to combine these two logs first with a log property. Okay, so we have two logs added together. That's going to be like multiplication on the inside of the argument. So 3x multiplied by 2, that's going to equal 4. And so that means natural log of 6x is equaling 4. Now I can take e to both sides power, and that's why we always, when we were doing this, we worked to isolate the exponential or isolate the log so that we didn't run into any sort of like exponent property or log property issues where we were assuming things that weren't true. Okay, then that's going to be 6x equals e to the 4th power. I'm going to divide both sides by 6, and I would get 1 over 6 times e to the 4. Okay, so that's going to be answer choice B. Okay, yes, this one. All right, so we've got a cone filling up with water. A situation you might become more familiar with if you continue on and take AP Calculus next year. T equals 0, we're going to start pouring in. The rate that we pour into the tank varies in such a way that the depth of the water inside the tank increases at a constant rate with respect to time. This is very unrealistic, right? When we usually fill up a paper cup or a paper cone of water from like one of those water coolers, the water's coming out at a constant rate. Now, if you think about it, as the water comes out at a constant rate, the water level is going to rise a lot at first because there's not that much space for water to go in, and then it's going to slow down later because there's more cone. And that's the same idea that we need to be thinking about here, but this is just not the same situation. We're having the height increase at a constant rate. Okay, now, volume of water versus depth in feet. Actually, the rate doesn't even matter. We're kind of just comparing for the cone. Okay, now, as the depth of the water increases, we're going to have more water in there. So I can eliminate C and D immediately because these are decreasing. We know that the volume is going to increase as the depth of the water increases. So I'm going to go back to these two graphs and say, well, kind of what I would expect to happen is B, like, right, for the height to increase at an increasing rate, but that's not what we're looking at all. The volume versus the depth. And so what I'm, suggesting is that, A is what you would expect because the water level is rising fast at first and then slowing down. I just said B. But maybe as the water level is going up along the red portion, I think we're not really adding that much volume. We're adding relatively less volume than as the water level goes up to here and then eventually goes up even higher. That's really what I'm talking about here. In the blue area, there's more space for water to, be. So as the depth increases, the volume is going to increase at an increasing rate. So that's going to be answer choice B. And that one is very tricky. I would say like significantly trickier than the other like filling bottle type problems that I've seen in AP Pre-Cal. But, for a practice exam, I think that's a good thing. All right, the binomial theorem can be used to expand an expression of the form A plus B to the nth power. That is true. Which of the following is equivalent to this binomial to the 5th power? Okay. What we're going to want to do, especially because this is like relatively unsimplified, we're not going to want to grind through this by hand. We're going to want to use the triangle. So the triangle starts with like 1s here, and then we kind of just add in the middle. 1, 2, 1, 1, 3, 3, 1. And we're going to go until we hit this 5. 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 5, 1. Okay, so now that I've got the numbers I need, I like to kind of arrange them vertically. So I'm going to just kind of do that there, and then go back and copy this in right here. 1, 5, 10, 10, 5, and 1. Okay, then I'm going to have the powers of x and the powers of negative 4y. And I think that's really what we're going to have to be worried about is the negative here. So I'm going to start off with x to the 5, and then I'm going to decrease the power of x all the way down to x to the 0. So it's going to be x to the 4, x to the 3, x to the 2, and x to the 1. Okay, and then x to the 0, I know that's equal to 1, so I'm just going to replace that with a 1. Okay, maybe taking negative 4y to various powers. Okay, so as the power of x decreases, the power of negative 4y will increase. So I go negative 4y to the 0, negative 4y to the first. Okay, and so they all start with x to the fifth. A is just clearly too good to be true. Okay, I would not ask you the question if that's how it worked. And then I'm going to look at the answer choices, and I'm seeing kind of some similar. I'm looking for one where all three are different. And I'm looking at that third power of x term. All three answer choices that are left are different. I'm going to emphasize that. I'm kind of looking here. Whoops, that's not gonna snap too. But you see what I'm saying? Like all three of those terms are different, so I should be able to make that determination just based on that term. Okay, so I'm gonna look at that over here, which is x to the 3, y to the 2. It's right here. Right, and then we're gonna have, all right, so 10 x to the 3 negative 4y squared should be positive. Okay, so that's gonna be answer choice C. All right. Then number 7, the rational function k is here. What are all intervals on which k of x is greater than or equal to 0? Okay, it's been a while since we've done this, at least in my class. I remember that we're going to identify our key numbers, put those on a number line, make a sign chart, and, hope for the best. All right, so my key numbers are the zeros of the numerator and of the denominator. But a hole in the graph did not necessarily count as a key number. I could simplify first, and if that made my life any easier. So that's going to be x equals 3, x equals negative 2, not because of that leading coefficient, because of that. I don't see why they would do that. Have that negative 2 out front, that's just like needlessly confusing, or you could be right for the wrong reason. But anyway, x equals 5 is the other one. Could just be like a negative 4 on the outside. That'd be totally different. But then, okay, we've got these three key numbers. I'm going to make a number line. Negative 2, 3 is here, and 5 is over here. All right, I'm going to choose a representative from each subinterval, so a number less than negative 2, like, I don't know, maybe negative 10. K of negative 10 is going to equal negative 2 times negative 10 minus 3 squared is a positive number times negative 10 plus 2 is a negative number, all divided by negative 10 minus 5 is also a negative. I've got 3 total negatives. That's an odd number of negatives. That'll end up being negative. All right, and something between negative 2 and 3, that would be 0. K of 0 equaling negative 2 is a negative number, negative 3 squared is positive, positive 2 divided by x minus 5, negative over a negative is going to be positive. Okay, k of x is greater than or equal to 0 from negative 2 to 3. What did I do wrong here? Greater than or equal to 0. Oh, maybe it just goes all the way to 5. Maybe there's not, maybe no sign change at 3. Okay, I can't figure it out based on the work I've done. I thought maybe after just 2, subintervals I could stop, but okay, I'm going to check k of 4. That'll equal negative 2 times a squared thing, which is always going to be positive. 4 plus 2 is positive, and 4 minus 5 is negative. Yeah, it's going to stay positive. Okay, and then continuing beyond that, negative 2 to 5. Okay, I think A is the only one that has that option. I'm going to finish out the problem just like so you understand what's going on here, but k of 6, something beyond 5 would be negative, positive, positive, divided by positive now, since we went bigger than 5, and then that would be negative. Okay, so we know that we're definitely interested in this area and that area. Then we would need to think about these kind of edge points. Are they included in our solution region or no? When x equals -2, the numerator is 0, k of x equals 0, that is greater than or equal to 0. Okay, that's n. When x equals 3, same story, it's part of the numerator. But when x equals 5, that makes the denominator 0. That's a vertical asymptote. It's definitely not defined, so it's not going to be able to be greater than or equal to 0 if it's undefined. And that's why it's -2 to 5, including -2, but not including 5. Alright, function j is given by j of x equals -5 times 1/3 to the x, which of these describes the end behavior of j. Alright, well 1/3 to the x, oh, that's a little rough. I think I can do a little better than that. Okay, that's better. So an exponential growth function is where we've got, the base of the exponential being greater than 1. 1/3 is not greater than 1. So each time x gets bigger, we're going to multiply by 1/3, it's going to get closer to 0. And so I'm going to say, okay, when x equals 0, j of x is -5/3, so the graph's going to be kind of down here. And then as x increases, I'm going to keep multiplying by 1/3, it's going to get much smaller, much closer to 0. Okay, that works too. And then when x goes negative, I'll end up, like kind of flipping the fraction and multiplying by larger powers of 3 times this -5, so it's going to be very negative. So I'm going to say as x approaches positive infinity, maybe this first limit right here, as x approaches positive infinity, j of x is approaching 0. And then over here, I'm saying it's going to negative infinity as I go to the left. So I'm going to say the limit as x approaches negative infinity of j of x. That's going to equal negative infinity. So it's looking for, where is it? That's going to be answer choice B. Okay, there we go. Now, function k is given by k of theta is 2 sine theta. What are all values of theta between 0 and 2 pi, where k of theta equals -1? Okay, we'll solve a trig equation. We've done that somewhat recently. 2 sine of theta equals -1. Honestly, this is best case scenario for us. This is one that I think we probably did pretty good on. So -1 divided by 2. Okay, looking for where on the unit circle is sine equaling -1/2? That's really high up, but it'll be fine. -1/2, not very far down, at least in the unit circle world. Try an exaggerated version. That's kind of like the first stop after 0, so that's going to be here. Down below the x-axis, sine is the vertical displacement away from the x-axis on the unit circle. So -1/2, that's going to be theta equals 7 pi divided by 6, just bigger than pi by pi over 6, and just less than 2 pi by pi over 6, 11 pi over 6. So go 7 pi over 6, 11 pi over 6, there we go, keep going. Which of these is equivalent when x is a positive number? Okay, so we're going to undo all the log properties. Okay, so division, I see that division right here. That's something I'm going to be able to kind of manipulate on. It's going to be a difference of 2 logs. So I'm going to have natural log of 2e to the 4 minus natural log of x to the 3. Okay, then I might, point out that these two things are connected with multiplication. So there's going to be addition there. And I'm going to say that, okay, that's natural log of 2 plus natural log of e to the 4. Okay, now you need to know that this thing here, that's just going to equal 4 because the natural log of a number is the special exponent we put on e to get that number. So if I put that, ask you what exponent do I put on e to get e to the 4, you would tell me 4. And that's why that log is 4. Minus natural log of x to the 3. Okay, now x to the 3 right there, that's power on the inside of a log, and the argument, we can swing that around the front. So like kind of a multiplier. Okay, so that's where I'm going to have log of 2 plus a 4 minus 3 natural log x. Okay, so 4 plus log 2 minus 3 log x. That's a right there. All right. Now, function j is given by j of x equals 8 minus 7 tangent of x over 4, which of these gives the vertical asymptotes of j. Okay, well, I just remind you that a vertical asymptote that comes from division by 0. number divided by 0. And remember, tangent is sine over cosine. So what we really need to be doing is thinking on the unit circle, like where does tangent have its vertical asymptotes? Just like maybe tangent theta, y equals tangent theta. Okay, and since tangent theta equals sine theta divided by cosine theta, it would be wherever cosine is equal to 0. So I'm thinking, where is cosine of theta equal to 0? Okay, well, that's where there's no displacement from the y-axis horizontally. That would be at pi over 2. And also at 3 pi over 2. Okay, but that's not what we've got. We're not looking at y equals tangent theta. We're looking at j of x equals 8 minus 7 tangent of x over 4. But really what matters is that this thing here is going into tangent, and I think about when that equals pi over 2 or 3 pi over 2, that's going to cause a vertical asymptote. So I'm going to say pi over 2 equals x divided by 4. And then I'd multiply both sides by 4, and I'd get x equals 4 pi over 2, which is going to be 2 pi. And then, okay, I kind of know that it's going to be probably this one, but I'll figure out what's going on with the other situation here. 3 pi over 2 is going to equal x over 4. I know that there's going to be other, the infinitude of solutions, but I figure I could just figure it out based on having 2 of them and looking at the answer choices, since this is multiple choice. So I'm going to multiply both sides by 4, have 12 pi over 2 is x equals 6 pi. Yeah, that I guess is plus 4 pi k. The next one would be, I guess, I'd have to add 8 pi, so it would be a 10 pi. Okay, I see what they're doing. 2 pi, 6 pi, 10 pi, they're all separated by 4 pi. Okay, that's great. Okay, now they're going to give us the end behavior of a polynomial. They're going to ask which of these could be an expression for k. All right, okay, I don't know why I wasn't seeing the nature of the question. All right, so the limit as x approaches negative infinity of k of x is positive infinity. All right, so that means the graph goes up like that. And then the limit as x approaches positive infinity of k of x equals negative infinity. So we don't really know what kind of polynomial we've got here, but we know that eventually it's going down to negative infinity, and it was coming from positive infinity. So it's going to look about like that. And based on that, I know that it has to be an odd degree with a negative leading coefficient. Okay, that's something that we learned in the polynomial unit. Odd because the end behavior is the opposite, and negative leading coefficient because as x approaches positive infinity, k of x approaches negative infinity. So the highest power term has to be multiplied by a negative leading coefficient. Okay, if we're putting in large positive numbers and getting huge negative outputs. So that's going to be answer choice. Okay, not B, that's an even degree, not D, that one's also even degree. It's going to be C because it's odd degree and negative leading coefficient. There we go. Right. Rational function here is f of x describing the output values of f as input values of f get arbitrarily close to 1. That means they're talking about a limit where x is greater than 1. Okay, so we're thinking about what happens as we approach there. Okay, that idea of a one-sided limit, we're going to be saying, really what we're doing here, and this is not really what the answer choices are getting at, but we're doing limit of f of x as x approaches 1 from the positive side. So what I'm going to think about is, what's happening when f of x equals, 1.1. So let's say f of 1.1, which is a little bit bigger than 1. Okay, and notice that there is going to be definitely like a vertical asymptote on the graph of f at x equals 1. And that's what I usually do when I work this type of problem. I just forgot to label it there. F of 1.1 is going to equal negative 2 times 1.1 plus 3, which would have been 4.3 divided by 0.1. Now dividing by 0.1, that's like multiplying by 10, so 8.6, that's going to be negative 86. Okay, now if you wanted to, you could probably, add, you could do 1.01 and see that it's even more negative, but we're getting a large negative number here, You know, and maybe this is 1.1 right there, and that's very negative because this thing is drawn very out of scale. But that means, you know, as we approach this vertical asymptote, we're not going to have a sign change between x equals 1.1 and x equals 1. We're approaching negative infinity. Output values decrease without bounding. Okay, so I would say the limit as x approaches 1 for the positive side of f of x is negative infinity. Or maybe that's what we'll say next year in AP Calculus. But all right, the graph of the rational function k has a hole at x equals negative 3. It's known that limit as x approaches negative 3 if k of x is equal to 4. Okay, so there's a hole at negative 3 and the limit of k is 4. All right, I think the fact that there's a hole, and I mean, we really, maybe I'll draw you the picture after. Okay, at x equals negative 3, I need to be seeing x plus 3 over x plus 3. So no, and I'm down to 2. Okay, so when I do that, I actually, you know, reduce. I'm going to have 4 times x minus 4 over x minus 1. And if I do the same thing for d, I'm going to have x minus 5 divided by x plus 1. Right, when they say that the limit of k of x equals 4, yeah, what we're going to do is we're going to kind of plug into what's left over and see, all right, 4 times, and then we're plugging in x equals negative 3 to see what would have happened had the, you know, we not had that, those redundant factors. Negative 3 minus 4 is negative 7 divided by negative 3 minus 1. Okay, that's a negative 4, so it'll be negative of negative 7 equals 7, so that's not right, so it must be D. Okay, but we know, we'll know that's true for sure if we do negative 3 minus 5 is negative 8, divided by negative 3 plus 1 is negative 2, negative 8 divided by negative 2 equals positive 4, yeah, that's, I like that. Okay, and that's going to be answer choice D. Now, this graph shows a polynomial function p. One of the zeros is 2 minus 3i. What's the least possible degree of p? Well, okay, least possible, I know that that right here looks like a double root. Okay, it's bouncing. Okay, so it's an even multiplicity root. I guess the minimum it could be would be 2. And then I'm going to have a single root right here. So I'm already sitting at degree 3 because I've counted 3 roots. But then remember that complex roots come in conjugate pairs. So that's going to be at least 2 more. So the least possible degree would be 5. So let's write that in, and it's okay. So I'm counting 2 plus 1 is 3. 2 more would be the very least because we know that, by the pairs, they're conjugate pairs, and by conjugate, okay, if it's 2 minus 3i, that its conjugate is going to be 2 plus 3i. Right. But you don't need to know too much about complex numbers for this course. Just that they come in complex pair or conjugate pairs to when they're roots of polynomial equations, and also what's the other thing? Oh, that we can express their coordinates polarly if we want, but that's, you know, hardly ever actually about imaginary numbers. It's more about trig. We got f of theta equals negative 3 sine of 3 theta. Okay, with these AP Pre-Cal polar graph questions, my strong recommendation is just plug in the major points, check, and eliminate. Okay, so theta and f of theta, or r. Okay, I'm going to plug in theta equals 0 and see what happens. Okay, we need to know that sine of 3 times 0 is sine of 0. We need to know that's 0. And I would really prefer for you to know that just like really mentally off the top of your head. But if you don't, we're drawing a circle. Okay, theta equals 0 is right there. So sine of 0 is the vertical displacement from the x-axis, which is going to be 0. Okay, so theta equals 0, r equals 0. Okay, when theta equals, let's say, pi over 2. Okay, negative 3 times the sine of 3 times pi over 2. Okay, 3 pi over 2 is right there. sine is -1, so -3 times -1 is 3. And I think that should probably be enough. Yeah, we need to be seeing theta equals pi over 2, r equals 3. That's only this point right here. And then we're not seeing theta equals 0, or we're not seeing like any point on theta equals 0 elsewhere, but really this is the only one that has pi over 2 and 3. So if we just went through, and my next one was going to be theta equals pi, I would have gotten r equals 0, so that could have meant that like this would have been like bad here, and that one would have been bad there, because I knew that at both 0 and pi for input values, f of theta was going to equal 0. But really pi over 2 was the one that showed me. Alright, then, let's see. F is an odd function. Remember, when they say an odd function, they don't necessarily mean an odd degree polynomial. They mean that f of negative x has that symmetry across the origin. It's the negative of f of x. Okay, and then the table gives values of f at selected values of x, where a and b are constants. It's the value of a plus b. Okay, well, if we know that f of -2 equals positive 10, okay, you could either use the equation if you're more algebraically minded, or you could draw a picture if you're more graphically minded. -2, 10 up here. Okay, so that means I'm going to have a point that corresponds over there. It's going to be where x is positive 2, a is going to equal -10. Okay, get rid of those. Okay, what kind of corresponds with b and -7? Well, probably something with an output value of positive 7. Okay, so -4 and 7, so -4, positive 7, okay, so that would mean positive 4, -7. Okay, so b equals positive 4, -10 plus 4 is -6. All right. Now we've got a figure showing a graph of a trigonometric function g, which of the following could be an expression for g. Okay, 4 sine of 2x. Okay, I think with these, it's been that long. We should start with the period and amplitude, I think, or no, amplitude and midline is going to be the way for us to go. Okay, so the minimum value is y equals -2, the maximum value is 6. That means the midline would be halfway in between. We would average them, so it would be y equals 2. Okay, and I am seeing that that does look believable. Okay, but these all have a midline of y equals 2, so that was not helpful at all. Okay, now I'm going to think about from 2, how far do I go up to the maximum, and how far down do I go to the minimum? That would be 4. Okay, yeah, that's 4. So 4, and these all have a multiplier of 4. Okay, I did not read the question all that carefully, but I still think that was probably the thing to do. All right, so if we're going to start off with no phase shift, okay, because these all, now that I'm looking at it, they all have the same, like, the multiplier for the period and everything. It's just a question of phase shift. So if we phase shift nothing, and we start at the, x equals 0, we're starting in the middle going down. That needs to be negative sign. Okay, so this is positive sign, that's out. That's at least how I think about it. Okay, if we started at theta equals pi over 4, which we would if we were shifting right by pi over 4, those are phase shift, that's at the very bottom of the sine wave. That's negative cosine. Okay, but I'm looking at a positive 4 cosine, so that one's out too. -4 sine x minus pi over 2. Okay, here I'm in the middle going up. Okay, that would be positive sine. Okay, so that one's wrong also, so it must be D. What's going on here? 4 cosine of 2 times x minus 3 pi over 4. Okay, the phase shift means we kind of like start our perspective here. That is at the top. That is positive cosine. That's going to be answer choice D. All right. Now, we've got an exponential function, which the following is an equivalent form for j of x. Okay. Well, all right, what we're going to need to do is use, kind of an exponent property on that 4 to the x plus 2, because there's nothing you can really do to combine the 3 and the 4. So I'm going to say j of x equals 3 times 4 to the x plus 2. Well, 4 to the x plus 2 can be rewritten as 4 to the x times 4 to the 2, and that's an exponent property you need to be very comfortable with in AP Pre-Cal. The fact that when we multiply two numbers with the same base and different exponents, we're going to add the exponent. Okay, when I ask students, like, how many x's is this, they're very confidently able to tell me that this is x to the 5. I'm going to go to 5. This is 5 powers of x, but sometimes, splitting something like 4 to the x plus 2 up into 4 to the x, 4 to the 2 is not as natural, okay, but I'm telling you they are exactly the same thing. All right, then I could say, all right, 3 times 4 to the 2, well, I'm just going to do one step at a time here. 4 to the x, 4 squared is 16. 3 times 16 is 48. I still have a 4 to the x here, and then that's going to be answer choice B. Now we've got h of x equaling f of x divided by g of x. We're thinking about rational functions, which this is a slanted asymptote. All right. Now, if they say slant asymptote, we know that we probably have a situation where the degree of the numerator exceeds the degree of the denominator by exactly 1. F has to be 1 power higher than g. Yes, negative 2x squared versus x. What we can oftentimes do is take the leading the leading terms and say, all right, negative 2x squared divided by x equals negative 2x, and a slanted asymptote is going to be parallel to that. Okay, well, that doesn't really help us all that much. That only helps us eliminate answer choice D. If we want the actual equation, we have to do long division. Okay, now this one is set up for synthetic division because we're just dividing by x minus 3, but evidently synthetic division is not supposed to be part of the AP Pre-Calc course, so I'll just do it with long division. Okay, but if you want to do this with synthetic, be my guest, like that's just as good. It's all the same numbers and you get the same results, so I would not care. Okay, that was x minus 3, I think. I should probably make sure of that. Nope, it was x plus 3. That was... Right, there we go. Okay, so what do I multiply x by to get negative 2x squared? We get negative 2 and an x. I'm going to distribute the negative 2x across the x and the plus 3. And 6x. I'm going to subtract that. And I'm going to be left with, all right, 0, 3 minus negative 6 is positive 9. And, all right, what do I multiply x by to get 9x? That would be a positive 9. Negative 2x plus 9, that'll be enough. There's going to be a remainder and whatever, but that's, what makes it an interesting rational function. We're just interested in the slanted asymptote, and that'll just be what we can read off right there. Next one is, I remember this one. So, angle theta is all the way out here, right? So point P, what you're supposed to see is that the coordinates of point Q are negative 4 and 3. I guess you can know that by the fact that they're sketched in the right angles there and stuff, but that's what we need to know, is that the coordinates of point Q are negative 4 and 3. So what is cosine theta? Okay, well, and then the radius of the circle is 5. If I just drew a representative triangle, okay, a reference triangle, okay, over here it looks like this leg would be negative 4, that leg would be 3, hypotenuse would be 5, and that angle will be equivalent to theta, at least its cosine will be. All right, so cosine theta is adjacent over hypotenuse, negative 4 over 5. Each of these is an equivalent form. Worked one very similar to this, but that's all right. Okay, when we've got power of a power, that's where we're going to multiply the exponent. So I could say that's 4 to the negative 2, let's write it like that, to the xth power. Now 4 to the negative 2, remember that that's 1 over 4 to the 2 power. The negative exponent doesn't make it negative or anything, it just turns it into a fraction. Okay, so 1 over 4 to the 2 power to the x power, so that's 1/16 to the x. Number 23, g of x is log base 3 of x. What is the value of g of 1/9? Okay, well, that's just going to be plug in 1/9 for x. This is just like, do you know how to take a log? Yeah. It's actually a good question. The type of thing I really expected to be in AP Pre-Cal. Okay, so when you're taking a log with base 3 and argument 1/9, you're asking yourself, what do I put in this box? Okay, what power do I put on 3 to get 1/9? Well, to turn it into a fraction, like something that's less than 1, it's going to have to be a negative value. Okay, so I know it needs to be negative in there, and 3 squared equals 9, so I think it should be negative 2. The 1/2 power, remember the 1/2 power is the square root, okay, and the square root of 3 is not 9. 3 is the square root of 9, okay, that's something different. So that number that needs to go in the box, that's negative 2, so that's going to be g of 1/9. Alright, now what are all values of x for which log base 7 plus 2 equals, okay, this is another one we're going to have to use the log property. This is the second time this has happened in this problem set, so it shouldn't be a big surprise. Alright, so we're going to combine the logs by getting them first to the same side of the equation. So log base 7 of 4x plus 6, and then I'm subtracting that other log, which was log base 7 of x minus 1. Okay, here where I'm dividing, or pardon me, where I'm subtracting two logs, that is going to turn into division in the argument. Okay, to write it as a single log, so log base 7 of 4x plus 6 divided by x minus 1. Then I'm going to take 7 to both sides powers, so 7 to the 2 is 49. 7 to the log base 7, well, that's just going to be 4x plus 6 divided by x minus 1. Now, I do feel like this is the type of situation because we might need to make sure that we are not looking at some sort of like extraneous root or something. I just feel like this is the type of situation that could bring one of those up. I'm going to multiply both sides by x minus 1, so I'm going to multiply 49 times the x and the 49 times the negative 1. It's going to equal 4x plus 6. Then I'm going to, I guess, subtract 4x from both sides, so 45x equals, and add 49 to both sides, so that'd be 55. Alright, now I might divide both sides first. You know, I mean, if you're feeling like you are going to need help simplifying this fraction, this answer, because I don't see a 55 or a 45 anyway, I see both of these are divisible by 5, so 9 times 5 is 45. Let's divide both sides by 5. So 9x equals 11, x equals 11 divided by 9. Alright, now I like that, but let me just make sure that that's not going to cause me to take the log of a negative number or the log of 0. No, that's not going to happen. No, not there either. Okay, I feel good. I'm happy. Moving on. Alright, now we're going to think about these two exponential functions, and f is the ratio of them. Okay, what is the x-coordinate of the point where f of x equals 1? Interesting. Well, if the ratio of them equals 1, then they're just the same thing. Why would they oftentimes ask you where the two graphs intersect, and this is equivalent to that, but it's not exactly the same. Alright, whatever. So f of x equals 1. 1 is going to equal g of x, 4 to the x plus 1, divided by h of x, which is 2 to the 3x. Okay, I'll multiply both sides by 2 to the 3x. Okay, now if I want to take a log of both sides, really I think it would be most effective if they had the same base. Or if these two expressions had the same base, we could just kind of clearly equate the exponents if that was just like exponential equals exponential. So notice that 4 is 2 squared. So I'm going to just kind of like work on that relationship and say, all right, that's 2 to the 2 power. And I'm taking that to the x plus 1. That's going to equal 2 to the 3x. Alright. Then I'll have 2 to the 3x equaling 2 to the 2x plus 2, right? I'm going to have to double the exponent, multiply the 2 times x plus 1. I'll distribute the 2 over the x and the 1. And then I'll say, alright, well, you know, kind of at this point, I can see 3x is going to need to equal 2x plus 2. Then I'll subtract 2x from both sides, and I'll realize, x needs to equal 2. Okay, then what you could do is you could go and just kind of check this. I really don't think it would be all that hard. X equals 2, 4 to the 3 divided by 2 to the 3 times 2 is 6. Okay, yeah, both of these are 64. Or you could think about 2 to the 6 is 2 squared cubed, and it all works. All right, or 26. This one's only 28 questions. So the table shows values for f at selected values of x. Which of the following claims and explanations is going to fit the data? All right. Okay, what are we noticing on the table? Okay, it kind of looks backwards, right? F of x is going 2, 4, 6, 8, 10, and x is really going downhill. This looks kind of backwards from what we're expecting. Usually x is evenly spaced and f of x has action. Okay, so really, I mean, if you see that like really inverse relationship and they're like, oh, exponential versus log, oh, it must be log, right? Because log is kind of like by nature an inverse type function. Okay, so I'm thinking it's log because x values form like a proportional geometric sequence, an exponential pattern, while the output values form a linear pattern, increase in equal length intervals. Yeah, so output values change, input values change proportionally, output values increase in equal length intervals. That's answer choice C. Always got to read through that twice, just make sure you're choosing the right one. All right, which of these is the range of h? Okay, 2 cosecant of 4x. What we're going to need to do to think about that is kind of like the underlying partner function to h of x. Okay, 2 cosecant is going to be very related to 2 sine. Okay, so I'm going to draw the sketch of y equals 2 times the sine of theta. I don't even need to worry about 4x, is kind of my point. Right, so 2 times the sine of theta is going to look like this. Oops. Come on, there we go. Okay. Now, if we wanted to think about h of x, okay, we'd just kind of be thinking about y equals 2 times 1 over sine. Well, when sine is equal to 1, the actual sine of theta, okay, cosecant is also going to equal 1. So that's going to be the point that they share. And then when sine should equal 0, that's where we're going to have a vertical asymptote for cosecant. What I'm saying is this is kind of what the graph of this h of x is going to look like in black. So let's copy like that. That was terrible. I should have obsessed over it so much. There we go. And then this one is going to be like that. I can do that so much quicker and it looked better. We can even get rid of the graph of y equals 2 sine x, but if we think about what was actually going on there, the midline was 0 and the amplitude was 2, so it should be, b, yeah, just like that. Okay, and you probably could have figured that out sooner. I was just wanted to give, full explanation to all these. You get 80 minutes, I think, for this section, so I think I'm still way under time. So the function f is given by 3 plus 2 e to the negative x. When is f of x equaling 11? Right, so 3 plus 2 e to the negative x equals 11. I'm going to isolate the exponential by subtracting 3 and dividing by 2. I'm going to take the natural log, wait, no, just a second, let me get rid of that. E to the negative x equals 4. I'm going to take the natural log of both sides. Log of e to the negative x is just going to be negative x equals natural log of 4, and then we're going to multiply both sides by negative 1, and we're going to get x equals the negative of natural log 4. Now I'm kind of interested that they left that way as answer choice C. I would point out that that negative multiplier could be applied up there as an exponent, and we could call that the natural log of 4 to the negative 1 power, which would be the natural log of 1/4. I would not be the least bit surprised if, on your AP exam, if you got a problem like this, you might see the correct answer choice, with a log properly applied to it. You will not see that anymore in AP Calculus, though, okay, because that's now very firmly a pre-calculus topic. All right, now we're going to move on to Section 1, Part B, which is multiple choice calculator. There's only 12 questions, and we get 40 minutes. Okay, and it will not take us 40 minutes. Now, think about expectations for this one. We should not expect to use the calculator on all 12 questions. That's just not how this exam is going to work. It's going to maybe be a couple before you even need it. And when we need it, I'll bring it in. Otherwise, I'm not going to be, having a calculator sitting off to the side and not using it. All right, so the figure shows the graph of h in the xy plane with 4 labeled points. It's known that the relative maximum of h occurs at x equals c. I can see that. Which of the following pairs of points is the average rate of change of h the least? Okay, so remember, average rate of change is the slope of the secant line, which is the line that connects the 2 points between A and C. All right, so I'm going to try to get that there. Okay, that's approximately it. But between points B and D, that looks a little bit more negative to me. That was awful. Let's try that again. Okay, that's closer. Yeah, that is more negative because this one was, A to C was actually probably more negative than it should have been. Okay, so that looks most negative. Okay, that's the least. And then B and C, I didn't do B and C. B and C is positive, so that's not going to be the least. C and D is very negative, though. Okay, that's going to definitely be the least slope because it's the most negative. All right, C and D, yeah. Right, let g be the piecewise defined function defined by g of x equals this stuff on that domain. What's the average rate of change of g over the closed interval -2 to 4? So I just need to think about, for average rate of change, g of 4 minus g of -2 all divided by 4 minus -2. Okay, so that's going to equal g of 4 is, 4 is between 2 and 9, so that's 3 plus 2 4s. I'm just going to leave it like that and deal with the arithmetic after. I've got a calculator in case I need it, but I don't think I'll be needing that. 3 plus 8 minus g of -2. G of -2. Okay, well, -2 is between -5 and +2. So I'm going to do 1 minus the square of -2. 1 minus 4 is -3. If I'd written it as 1 minus 4, I'd have needed to put it in parentheses, and that seems a little risky for y'all, so I'm just going to do the computation mentally. 11 plus 3 is 14 over 6. Okay, those are both even numbers. I can at least divide them in half. 7 over 3, that's answer choice D right there. All right, now 78. The graphs of the linear function L and the exponential function E both pass through 0, 2, and 1, 6. F is given by L of x minus E of x. What is the maximum value of F? Okay, well, linear function L and exponential function E. Okay, yeah, I'm going to have to use a calculator for this one. All right, if they're telling me that I've got 2 different functions running through both of these points, I should probably just edit the lists and run 2 regressions. I think it's going to be the way for me to go. And clear that one out. Okay, the points were 0, 2, and 1, 6. So, I know those are covered up, but I think it's alright. I can just tell you saw it earlier. Okay, what is the maximum value of f? Okay, but first I need to do linear function L. So I'm going to go over here, do a stat, calculate a linear regression. I'm going to store L into y1. Calculate. Even though we could have easily computed that, right? We could have gotten 4x plus 2 off those 2 points. Maybe actually faster than we did that. Now that we need to do an exponential, though, doing 2 of these by hand would probably take considerably longer than I've spent on this. I'm going to store the exponential in y2, and that might be a good thing to make note of on your paper, like, hey, I did L in y1 and E in y2. Now we should never do that in free response, right? Because we don't use calculator notation in our answer for free response. Moreover, the reader doesn't know what we mean, really. We use calculator speak like that. Okay, so we've got them loaded up in here. We did those. And really what we're interested in is f of x equals L minus E. So y3 is going to equal y1 minus y2. It's going to be a course of action here. Now, I want to find the maximum value of these things. I'm going to go up and I'm going to turn off the graph of these, because I don't really want to have the calculator waste. Oh wait, I didn't turn it off. Okay, enter. Okay, I want to have it waste time on graphing y1 and y2 before graphing the thing I'm actually interested in. This is not going to be the window I want, so I'm going to act like I'm turning the calculator off and zoom back to standard. Okay, here we go. I'm just going to hope for the best on the standard window. I think, there we go. Yeah, okay, yeah, we can find the maximum. So we're going to use that maximum command. It's still graphing, and let it think for a second. All right, calculate a maximum. Okay, that is to the left of the maximum. Looks like x equals 1 is to the right of the maximum. Okay, it's going to give me the coordinates there. Now, 545 and 540. Okay, I think it would have been nice for them to have 545 as an answer choice, because remember what they're looking for is the value of f, like the output value of f, the y coordinate there. So that's going to be 0.540. All right, now looking at this one, I'll take that away for a second. Whoops, there we go. Certain hobby shop wants to attract customers on slow sales days. Oh, we've seen this question already this year. If we make purchases on successive Wednesdays, discounts doubled from the previous Wednesday. All right, so 1.5% on week 1, 3% on week 2, 6.6 or 6% on week 3. Based on this pattern, what is the first successive week that a customer's discount would exceed the purchase price of an item? Okay. I'm trying to think how I want to do this. It's because 6, 7, and 8 and 11 are like all very close to one another. I should probably like write an equation and be like really certain about it. So we see a doubling pattern that's very exponential. So I'm just going to say the discount rate, R of t, feels like something times 1.5 to the t. Okay, a times 1.5 to the t. Now, really what I want is for it to be 1.5 when t equals 1. So I think what I want to do is make that a t minus 1. And then think about it that way. Oh, wait, whoa. This is not right, because I'm not multiplying by 1.5 each time. I'm multiplying by 2 each time. I just didn't multiply by 2 the first time. Yeah, okay, now I can put the 1.5 out here, and then I'll have something that'll be just right. Yeah. Now, if you wanted it to be 2 to the t, you could figure out, okay, when t equals 1, 2 times what is 1.5, and you get, I think 0.75%. Okay, but let's just wrote it like this. I'm going to go with it. Okay, so r of 1 is equal to 1.5. R of 2 equals 1.5 times 2 to the first is 3. R of 3 is 1.5 times 2 squared, which is going to be 6. This makes a lot of sense. Okay, I'm going to go back over the calculator and use it. I don't know if you really need it for this, but I guess it depends on your arithmetic skills. I'm going to go over here, kind of clear out. Oh, whoops. Is that going to? No, that definitely didn't do it. I don't know what the button is on the keyboard for clear. Let's figure it out. Okay, so in y1, I'm going to do 1.5 times 2 to the power of t minus 1. I'm just going to use the table. What happens? All right, there we go. And I'm going to use the table. I'm actually going to have it ask me for the independent variable. I really prefer to use the table that way. But if you wanted to start at 0 and just scroll through it, I do not want to graph. All right, I want to table. I'm just going to type in 6. Okay, not sure why I didn't like that. X equals 6, X equals 7, Okay, that's a 96% discount. X equals 8, 192%. That's the first time that the discount exceeded the purchase price, because that would be 100%. Okay, when t equals 11, I'm not sure why we would want that, but okay, there we go. All right, t equals 8. All right, now number 80. Function g is constructed by applying 3 transforms to f in this exact order. Horizontal dilation by a factor of 3. Okay, so we replace x with 1/3 of x. Okay, so I start with f of x, and then that horizontal dilation by a factor of 3 is going to be f of 1/3 x. Okay, the vertical dilation by a factor of 5. Okay, I'm going to multiply this whole thing by 5. Okay, and then a vertical translation by -7 units. Okay, I'm going to just subtract 7 after the fact. Okay, so it's going to look like that. And so 5f of 1/3 x minus 7. Okay, 1/3 x minus 7. There it is. Okay, we got that. We can do those. Okay, number 81. Let h be a function where when the output values increase without bound, where they are increasing without bound as the input values increase without bound. Okay, so that means the limit as x approaches positive infinity of h of x is positive infinity. So, I know that limits are something that at least the students in my class this year are feeling not all that confident on, so I'm just going to write it out every time. Okay, so output values increase without bound, h is approaching positive infinity as the input values increase without bound as x approaches infinity. And output values of h decrease without bound as the input values decrease arbitrarily close to 0. Okay, so that means limit as x is approaching 0 and it's decreasing towards 0, so it's approaching from the positive side of h of x. That's going to go to negative infinity. So I need to see a vertical asymptote at x equals 0. And okay, that's going to be, and then approaching positive infinity, that's going to be answer choice B. There, okay. Alright. Sine theta and sine of theta plus 2. Or theta plus pi over 2. Equals 0 to 2 pi. How many solutions exist? Okay, well I don't know if you know the hint, but you can kind of see it's in a different font. It probably is a calculator question. You're allowed to use a calculator on this one. Might as well try. Now, the thing is, like, it kind of looks like a polar situation, but you actually don't want to graph this on polar. You just want to graph this on rectangular and count the intersections to find the solutions. So I'm going to go over here, clear this out. I don't know what the button would be, but clear it out that way. All right, so f of theta is sine theta, and as soon as we hit one of these trig buttons, we need to make sure that we're in radian mode. Okay, we are in radian mode, so we're good to go. You need to always be in radian mode in this class. So I'm going to graph sine of x, and then also going to graph sine of x plus pi over 2. And I believe in PEMDAS, so I know it's going to know what I mean when I do pi divided by 2 that way. If you were unsure, use the fraction bar, right? No shame in that. 0 to 2 pi, I'm going to set the window there, 0 to 6.28 or 6.3 or something like that. You can type in 2 pi if you like, but one intersection, 2 intersections, just 2. All right. So on the interval 0 to 2 pi, I counted 2 times where the graphs ran into each other, so that's how many solutions there are to f equals g. Oh, goodness. All right. Now, average daily temperature in degrees Fahrenheit in a certain city can be modeled by function f given by that business. Okay, c is a constant. January 1 corresponds to t equals 1. All right, t equals 10, the average temperature was 41.7. Based on the model, what was the predicted average temperature on February 28th. Okay, so really what we need to do is find the value of C. So if they tell me that f of 10 is 41.7, I know that a 41.7 is going to equal 63.6 plus 21.9 sine of 2 pi over 365 times t minus c. Now I do know the value of t, so I'm going to substitute on that. That's going to be t was equal to 10, right? And so I'm just going to try to solve this equation for c using the calculator. Okay, so on, 41.7 is bigger than 10, which is kind of my standard y window. I'm going to actually subtract 41.7 from both sides, but I'm not going to try to do that without a calculator, right? I'm going to go over here, bring back the calculator. Oh, whoops, wrong thing there. Okay, get rid of that. Okay, don't need these anymore. I'm going to find the zero of a related function. So I'm going to do 63.6 plus 21.9 times the sine, in radian mode, of, okay, I'm going to call for the fraction bar because there's just like kind of a lot of drama in this equation, 2 pi over 365 times, nope, t was 10 minus c, and that's the thing we're solving for, so that's like the variable. Okay, we're interested in where that's equal to 41.7, so the difference between that and 41.7 should equal 0. And that's a calculator trick we're going to employ quite a bit in AP Calculus. Now, I'm going to zoom to the standard window and just hope for the best. Just figure out what C is. Great. Okay, what is going on here? How am I supposed to figure this out? Think about this for a second. Alright, now I'm about to do something I am certain I have never done this on my YouTube channel. I'm going to use the equation solver. I hardly ever do this, and I have not had a lot of success with this in the past, but I feel like this is probably going to be the way to go. I want to solve y1 equals 0. So in equation 1 I put y1, in equation 2 I put 0, I press OK, enter. X equals 200 was kind of like my right bound. I have not pressed solve yet. Okay, when it says solve, really what it's talking about is this F5 button. So I press F5 and it's thinking, select variable, press solve. Okay, and then I get this 101.2499. Okay, I think that that's what I need. Okay, and so that's gonna be C equaling 101.2499. We've been through all this as a calculator multiple choice question. Let's just use 101.25 because these answer outputs are, they are kind of, I've got two that are really close together. I should probably go back and look at that again. Pardon me, this is using more than my allotted time for this problem, that's for sure. Okay, I'm going to do this. Yes, let's please solve. And then, okay, 101.2, I don't know, maybe I'm just being paranoid, but I'm going to copy all the decimals. 2499459. That has got to be enough. All right, so I'm going to go back in, and I'm going to kind of just edit this equation right here. So it's 10, so it's t minus c. So it's going to be x minus, I'm going to be inserting over this, be in front of this 101. Yes, I'm going to need to delete that. 2499. I think that was 459. I think I copied down one too many nines there. And then I will need to get rid of that minus 41 because that was just when I was trying to solve an equation there. All right, so now I'm going to want to plug in t equals, it looks like 59, and hopefully this did not test this out. resumed the recording. 49.0396. Okay, good. 49.040. That problem was a bit of a journey. All right, now a new special attraction opened at a museum. And I remember this one too. All right, so this is going to be a rate graph. And this is patently not pre-calculus, but that's just, I guess, not my place to say. I think if you've got a graph of a rate of change, that makes it the graph of a derivative, which is calculus, but okay, I've said my piece. So, right, M models the number of people that visited, but R is the rate of change in people per day for each day after the attraction opened. R is given by this, and which of the values of D does M have a point of inflection? Okay, M has a point of inflection when it goes from concave up to concave down, or concave down to concave up. When the rate of change of M changes signs. But maybe, yeah, goes from no, pardon me, it doesn't change signs. It's the rate of change of the rate of change changes signs. Okay, so it goes from increasing to decreasing, or decreasing to increasing. Okay, now the rate of change of M is R, so that's, we're going to graph R of T, or no, R of D. Okay, goes increasing to decreasing, or maybe decreasing to increasing. Okay, so let's get the calculator, let's just get to it. It's going to take me probably longer to type this in. 1 over 200, okay. 1 over 200 times the negative of d to the 4 plus 35d to the 3 minus 411d to the 2 plus 1845d to the first. Just like, what is the benefit of the numbers being this bad? 2686.5. We're going to graph it, and we're going to look at the answer choices for sure. We want to make sure that these values of d, which are represented by x in our graph, are something we're seeing. So we're going to set the window to be 0 to 15. And hopefully negative 10 to 10 is enough to see the action here. Okay, up, down, okay, yes, up. Okay, these are changes in decrease to increase. Okay, so there's 3 of them. I only see one place where there's 3 answer choices. Maybe I'll make sure that these local extrema, like these points here and there and over here, are actually those 3 x values that I'm seeing in the answer choices. So I'm just going to calculate a maximum. It looks like it's between, let's say, 2 and 6. All right, so a left bound of 2, a right bound of 6, I guess. All right, 3.894, yeah, that's the first one, answer choice D. I'm happy with that. Let's move on. That one's pretty tough for you as a pre-calculus student that really doesn't know all that much about rates of change, besides that they're the kind of some slopes. I don't know. Fearing a new computer virus. A security company performs a simulation to predict the number of computers might be affected by the virus. Okay, number of infected computers can be modeled by a geometric sequence. Okay, geometric sequence, that's a fancy name for an exponential function that only takes in whole numbers. Okay, the first day of the simulation is day 1. On day 6, the virus infected 750, and on day 10, the virus infected 3,200. How many on day 14? All right, so on day 6, we'd done 750. Let's do an exponential regression. We got a calculator anyway, right? Okay, so I'm just going to say on day 6, I edit the lists that we told us about day 6, and then day 10. 3,200 on day 10, and it said 750 on day 6. I'm going to run an exponential regression on this one. I'm going to store it in y1. Yeah, that's that one. That 1, calculate. Okay, now on day 14, I'm going to call for y1 of 14. Oh, whoops. Okay, do that. And 13,653. Okay, there we have it. All right. I think exponential regression was definitely the way to go there. All right, table gives values of polynomial function g at selected values of x. Which of these statements of g could be true? Okay, g is an odd function. We already talked about that earlier. I probably need to tell you about even, remind you about that. So even function is where f of x equals negative f of negative x. What that has to do with even degree polynomials is that a polynomial will be even if it only has even power terms. Okay, so f of x equals f of negative x. That's obviously not happening because f of 2 and f of negative 2 are negatives of each other. All right, and g of 4 equals the negative of g of negative 4. This thing is looking like it's odd. Okay, so even is out, odd is in, and g of negative 1 would be the negative of negative 6. It needs to be positive. Okay, so there we go. Kind of weird that we had odd function twice and even function no times, but that's why this is just a practice exam that we kind of cobbled together at the end of the course. All right. Here we've got table giving the population in millions of a certain region for selected years. Exponential regression is calculated for the 5 data points. Great. In what year will the population first reach 35 million? Okay, so we're going to go into the stat menu, bring back the calculator. Stat menu, edit the lists. Okay, x equals 4 represents 2004. Okay, so 4, 8, 12, 16, and 20. And 22.4, 24.3. 26.0, 27.9, and 29.2. We're going to do that exponential regression. Store that in y1. Yeah, because we're going to need to go ahead and graph this and find out where it reached a population of 35 million. Okay, so we're going to be interested in where this thing hits 35. So what I'm going to do is I'm going to go up and I'm going to turn on plot 1 so that I can zoom to stat. I don't know that that actually turned it on. Okay, now I think it's on, yeah. Now I'll go over here to zoom to stat is option 9. And there we go, I've got this exponential growth pattern. If 35 is not in the window, then I can just expand it a little bit. Looks like it's not. Okay, that's kind of a shame, but that's a good place to start, right? Yeah, the y max was 30. We should make that 40. So we can comfortably see the intersection. Oh, no, we're going to need to look out in the longer term. I can already see that, so let's just kind of double the x window, make it 2 to 40. That should do it for us, I think. Yeah, that'll give us a full picture. We'll see the intersection. It'll be great. It's graphing. Here comes the horizontal line. They intersected. Let's calculate the intersection between blue and red. Give it a guess. It's going to be 30.149. Okay, so what year? It's going to be 2030. Okay, there we go. All right. Okay, and that's the end of the multiple choice section. Okay, so we're going to move on to free response now. And the first part of the free response allows the use of a calculator. Wait, whoops, second plus 7, 1, 2. I'm just going to clear out the RAM and start fresh. And all right, here we go. So let's work on the free response questions for this practice exam. Okay, we're starting off with the first two, which allow the calculator. We already know what's going to be on them because the free response is fully prescribed in AP Pre-Cal. Right, so the first one, we're going to need kind of some room to write here. Okay, we don't need to see that. I'm realizing I need to get this thing ready to write. Alright, so number 1 is gonna give us a graph or a table. It's gonna do some composition of functions and the solving. We're gonna be able to use a calculator, kind of all over the place. This is another one I kind of wish we'd brought out a little sooner for you to grapple with, but y'all are doing really well, or at least kids in my class this year, y'all are doing really well on it. Hopefully, if you're watching this in the future, you're also doing well with free response question 1, because it's not too hard. H of x equals g of f of x, which can also be written with the more common notation g of f of x. Okay? Find the value of h of 3. So this is going to be a1. So that would be h of 3 equals g of f of 3. We're looking at a picture of the graph of f. F of 3 is looking like 2. So this is going to equal g of 2. And, okay, find the value of h of 3 as a decimal approximation. Well, g of x equals 2 plus 3 log x, so that's going to be 2 plus 3 natural log of 2. Pardon me, I said log. I meant natural log. In general, when I say log, I actually do mean natural log, but I'm going to, get that calculator out and do 2. Okay, now 2 plus 3 natural log of 2, and I'm going to get 4.079. So I'll kind of report that there. Don't need the calculator any longer. Equals 4079. Remember, always 3 decimals. Always. So find all real zeros of f or indicate that none exist. Okay, we're looking at a picture of the graph of f, and well, they told us that the points -1, 0, and 3, 2 are on the graph of f. I feel like that was pretty helpful. Part A2, I'm just going to say x equals -1 is the only one I'm seeing. Decreasing function f on its domain of all real numbers, except where x is -1. Okay, here we go. So next, for part B, we're going to be finding all values of x as decimal approximations, so we need to use calculator, where g of x equals e. Alright, so 2 plus 3 natural log x equals e. I think it would be tempting to try to solve this one by hand. We don't need to, right? We've got a calculator. So we're going to go over here, we're going to type in y1, 2 plus 3 natural log x, and then y2, e, and we're going to see where they intersect. Okay, so going over here to y equals 2 plus 3 natural log x. And then I'm going to type in e down there. Okay, where even is that? That's over here by that, but if you couldn't find that, we know e to the x is above natural log. You could do e to the 1, that would also work, right? And, okay, we're kind of on the standard window. Yeah, we should be able to find that. Okay, we see them intersecting. We're going to calculate the intersection between blue. Okay, and if it gave you an error, so then we need to make sure we're actually on the blue curve. I don't know if that would have happened there, but I feel like that might happen sometimes. Okay, I've got what I need. I'm seeing that value. That's what I'm going to be taking right there. Oh, wow, you can't actually see that. Ooh, that's not quite right. Didn't realize that my calculator was, I don't know if I can make that quite, okay. You see, I'm grabbing that number right down there. Hopefully you're working along on your own calculator. That's 1.271 or 1.270, depending on if you like to round or truncate. So that's going to be x equals, no, I can't see it, 1.271. Okay, now, I'm not sure about this because, we've not actually seen the scoring notes for the free response for a real AP Pre-Cal exam yet, as of when I'm recording this video, but I think you might be able to get away in AP Pre-Cal with just like reporting x equals 1.271, like a bald answer, but I really don't like that because I teach AP Calculus and that would not fly on the free response in that class. Anytime we solve an equation in AP Calculus with a calculator, we do have to show the equation that we solved, so I think it's going to be, definitely best for the students in my class, for almost all of which are going on to calculus next year. You need to show what equation you're solving using the calculator. It's just the best practice. So, okay, there we go. Determine the end behavior of g as x increases without bound. Okay, that means we need to be thinking about the limit as x approaches positive infinity. Okay, and it's going to say express your answer using the mathematical notation of a limit. That means you cannot write a sentence as x approaches infinity, y approaches that. That is not the mathematical notation of a limit. Okay, the mathematical notation of a limit, we start off with a lim. Okay, we say what x is approaching right below the limit. I don't know where we went wrong this year in showing you how to like the notation, but so many of my students were on free response were putting the x approaches stuff somewhere else besides underneath the limb, and that's not where you're supposed to put it. And like we're going for standard mathematical notation here, so we do need to like kind of do it the right way. So the limit of g of x as x approaches infinity. I didn't even put positive infinity because it's increasing without bound. Okay, well, 2 plus 3 log x, we could look at it at the graph. I mean, could bring it back up for you in here. Look, it's the blue curve. As x approaches infinity, y is going to be approaching positive infinity. Yes, here we go. Log does not have a horizontal asymptote. What would it be approaching? You know, what would you think the horizontal asymptote would be? There's no, upper limit to the exponent we can put on e, so there's no limit to log. So this limit is positive infinity. We're just going to write it like that and move on. Okay. Now, part C. Determine if f is invertible. Okay. Now, I'm going to say, then this is a yes-no question. Yes, f is invertible. Okay, there's a variety of reasons that work, but, our reason has to be accurate. I'm going to write a variety of reasons for you that could potentially, earn the credit. One reason, based on the definition of a function in the graph of y equals f of x, I didn't notice that. Okay, I don't know that, yeah, that's not going to, I was going to say because f is strictly decreasing on its domain, a function that's monotone is going to be invertible. A function that is, that's an injection, which this one is going to be invertible, but that doesn't necessarily have to do with the definition of a function in the graph of y equals f of x. Okay, now the graph of y equals f of x. Basically, yes, because each output value, each of the y coordinates is only hit by one x value, right? Most one x value, but each output value corresponds to a unique input variable. A unique input value, pardon me. And that's going to have to do with the definition of a function, right? Because when we think about the inverse function, that's taking in y values and returning us the x's that got us there. And if it's going to be a function, it can only return us one x, where it corresponds to a unique input value. Okay, but I think another valid answer would be, all right, if f is, we don't have an equation for f, but if we did somehow happen to know that f of x equaled, it's not going to be 2 over x minus 1 plus 1. Is that part possible? Okay, 2 over 3 minus 1 would be 2. Yeah, that one works when x equals negative 1. So that does seem to be an equation that works. I guess that's kind of taking a lot on faith because they just told you it was a decreasing function where x is not equal 1. This seems to work. It fits the points. I wouldn't do this on mine. I would definitely write the sentence that had to do with the definition of a function. But if y equals that, we could solve for the inverse, right? We could say y minus 1 equals 2 over x minus 1. We can multiply both sides by x minus 1. Okay, this would be a little bit unpleasant. And then we could solve for x eventually. I'm really running out of room here. Run on this sheet. I guess I could just keep going. And then I could say x equals 1 plus 2 over y minus 1. That's a formula for the inverse. I could say f inverse of x is equal to 1 plus 2 over x minus 1. That's a function in its own right. So I think you could say, hey, I solved for it. If you had an equation, you could say, hey, I solved for the inverse and it's a function. But we didn't really have that formula, so I don't think that was valid. I'm going to move on. Okay, so that was free response question 1. Okay, free response question 2, still allowing the use of a calculator. Oh, no, what's going on here? Okay, no, that's not good. All right, free response question 2. This is going to be modeling a non-periodic context, so possibly exponential, possibly logarithmic, possibly quadratic. Here we've got a piecewise model. Okay, so initially 7 students knew about the rumor. After 2 hours, 15 had heard the rumor. After 6, 67 had heard it. Here we've got a piecewise function r. Use the given data to write 2 equations that can be used to find the values for constants a and b in the expression for r of t. All right, well, oh yeah, this one's a little bit different. I think we will. No, we're not actually running a regression on this one, but usually we do. Okay, but we don't necessarily know that we're always going to for number 2. All right, so for 2 part A1, he told us that at t equals 2, 15 had heard the rumor. Yeah. So we're going to need 15 equaling 7 times a to the t equaled 2 at that point, 2 over 2. And then the other thing we know is after 6 hours, 67 had heard it. So 67 equals, and 6 is, okay, that's where t is greater than or equal to 6. So I have to use that negative 213.29 plus b natural log of, in this case, 6. Okay, so we're going to be able to figure that out. I think we're just going to have to, actually do the algebra, though. Okay, so 15 equals 7 times a equals, not again, I'm thinking 15 over 7, so a is 15 divided by 7. B is going to, but they want a decimal approximation, so I can give them that here in a second. B natural log of 6. Okay, maybe I'm just going to kind of do some work here. 67 plus 213.29. And then to solve for B, I'm going to be dividing by the natural log of 6. And I guess with my handwriting, that kind of looks the same. Natural log of 6. All right, so now I'm going to need a calculator for sure. I'm not that quick with mental arithmetic. Here we go. All right, that's, okay, what is going on? Okay, so quit out 15 divided by 7. That's the easy one, 2.143. And then this one, let's bring out the fraction bar. We want to be careful there. 67 plus 213.29 divided by the natural log of 6. That's 156.433. Okay, now I am going to go up and I'm going to store these values because I'm going to be using them later in the problem probably, and I do not want to be using rounded values. Wait, no, I don't. I'm going to stow to a, because that was the value of a, and I'm going to go up to this 156 number. I'm going to store that into b in case I need to use those later, which I'm sure I will. All right, now after that I've got, okay, so that's part 2 right here. Okay, then part B1 is using the given data to find the average rate of change, the number of students that have heard the rumor between 2 and 6 hours. Okay, so that's going to be r of 6 minus r of 2 divided by 6 minus 2, which is equal to 67 minus 15 over 6 minus 2. Now, it's important. I think this might be a situation where you are allowed to, give a bald answer, but I really don't like the sound of that. I think we should be showing the setup that leads to our calculations. 67 minus 15 over 6 minus 2, and then we would get 13. You can put 13.000, but you don't have to. And again, I'm going to give the units. It's not going to ask me to, but it's just a good habit. The units are going to be number of R's, students per number of T's, days, no, hours. So students per hour. And, okay, so I've got students per hour as my units, and, oh, it's very laggy, but it's all right. Interpret your meaning from part one in the context of the problem. Okay, well, we can do that now that we have, got the units also. From t equals 2 to t equals 6 hours, okay, the number of students who heard the rumor increased 13 students per hour. You just kind of leave it at that. Consider the values that result from using the average rate of change found in part one to estimate the number of students who have heard the rumor for times p hours, where p is between 0 and 6. Okay, well, we found that a was equal to 2.143. Okay, and it's an exponential function with a growth factor bigger than 1. So it's exponential growth. I just draw myself a little picture to, convince myself of that. If that's 0 to 6, okay, just draw it like that and say, okay, we use the average rate of change maybe from 2 to 6. This is very frustrating. And that's going to be a straight line, the average rate of change. If we, to estimate the number of students, Are these estimates less than or greater than the number of students predicted by model R? Okay, well, I would say these estimates from average rate of change they're going to be greater than the number of students predicted by R because the graph of R is concave up, right? It's that curvature that's keeping it below the straight line. Because the graph of R is concave up on the interval 0 to 6. Okay, I think that will be enough. Okay, there we go. That's B3. And remember my advice on B3, we're just going to do the best we can, right? Okay, it's very laggy, unsure of what it's doing on the left side, but just do the best you can. It's always going to be kind of a toss-up. And same story for C. The model R is valid for 0 to 12 hours. Explain how the range values of the function R should be limited by the context of the problem. Okay, well, the range values, that's the output values of the function, that's the number of students who have heard the rumor. Okay, it's valid for 0 to 12 hours. There's only so many students to hear the rumor at the school, right? There's not like a million students at the school that could possibly have heard this rumor that, know who Mr. Passwater is and are going to be like, hearing that he's won the lottery and moved to Japan. So range values should be limited to the number of students at the school. Okay, I think my tablet is tired as well. Yeah, range should be limited to the number of students at the school. And I don't even know if that would work. Okay, if you want to see more examples of me doing problems like this and being uncertain about the answer for C, I've got a video of it. There's I've got a few of these examples of free response question 2 that you can see, and see they're all kind of like that a little bit. All right, now questions 3 and 4 do not allow the use of a calculator, so I'm going to actually close that out. I don't know if that's making my computer go slower or anything, but it's definitely my way. All right, so a windshield wiper blade on a car window rotates back and forth. Okay, so now we've got lag on the right side as well. Okay, when the wiper blade is farthest to the left or farthest to the right, the measure of the angle formed by the wiper blade in the vertical center line is, you can't see it, but it's 0.75 radians. And I tried to show you in that. Okay, there you go. That was probably a mistake. let's see if I can get that all in there, and it's probably going to be too blurry for you to even read. All right, at time t equals 1 second, the wiper blade is farthest to the right for the first time. Okay, so I'm going to say farthest to the right is, let's see, is that positive or negative? Positive value of h of t indicates the wiper blade is to the right. Okay, so farthest to the right, t equals 1, maximum value of h of t. So I'm just going to make that note right here at point F, that's going to be t equals 1. Okay, and that's the first thing that I see. Okay, then they say that the maximum number of radians is 0.75. So I would think that, yeah, it's going to be 0.75 up here and negative 0.75 down here, meaning 0 is the center. Okay, so we want the possible coordinates for t and h of t. Okay, now it should probably have given us, okay, then the wiper blade rotates left, passes the center vertical, or the vertical center line, and is farthest to the left again at t equals 2. Okay, so P is going to be t equals 2, so J would be 1.5, G is going to be 1.25, and J is going to be 1.75. Okay, so A, coordinates of F could be t equals 1, h of t equals 0.75. G is going to be t equals 1.25, t or h of t equals 0. J comes next, FGJ, so that's going to be 1.5 and negative 0.75. K, 175 and 0, and then P, the last point, will be 2 and 0.75, because I said it was back to the farthest left spot. Okay, so I've got possible coordinates for each of the 5 points. Okay, function h can be written in that nice form, a sine of b times t plus c plus d. Now, if we are going to write it like that with a positive value of a and its sine, okay, we need to be coming up through the middle. So we need to kind of probably be looking for that spot for our phase shift, point K. So I'm going to say, I think that would be like probably the easiest way. So for us, we're going to go over here and say, all right, part B is find the values for A, B, C, and D. All right, A is the amplitude, that's going to be 0.75. I think we can see that from the graph. That's how far we go up or down. D is the midline, that'll be 0. Okay, if we want positive sign, that's why I'm going to say, okay, we're just going to shift right, t equals to 1.75. Oh, whoops, still on highlighter over here. T equals 1.75. Okay, I think we should just shift right 1.75 units so that we've got what looks like, the start of a positive sine graph. And so if I'm shifting right 1.75, I need to have t minus 1.75. C is negative 175. And then B is going to be something I need to think about the period. Okay, so the period equals 1. So I'm seeing there from top to top. So period equals 2 pi over B. So that means B must be 2 pi. Okay, and it's coming. There it is. All right, now part C is something that I think we're doing all right. G is T1 and J is T2. So we're kind of interested in that portion of the graph that I've kind of emphasized in red. And so since we're looking here where the graph is decreasing and concave up, but that's actually, no, it's just asking about H. H is negative, right, because it's below 0, and it is decreasing. H is negative and decreasing. I'm going to clearly, I don't know if you're going to, I really don't know if you're going to be bubbling your answer. That's crazy. If you're going to be bubbling your answer, or just writing a letter D, that seems kind of risky, because it's like, you need a handwriting sample to be sure about what your letter is. Some of y'all, like A and D, might even look the same. Who even knows? Some will have interesting penmanship. But I'm just going to say answer choice D. Maybe they will give you a... okay. It's going to be all right. We're almost done here. So, and then C2, okay, describe how the rate of change of h is changing on the interval t1 to t2. Okay, well, at first, the rate of change is very negative, and then the rate of change is less negative and it's closer to zero, so the rate of change is increased. You could say, I think you can say increasing, and that'll be enough, like to describe what is going on with the rate of change of h. The rate of change is increasing because the graph is concave up. Less is more. I do not want you rambling, going off saying things that are untrue and talking yourself out of the point. So we're just going to be really direct with our answer, not even give a reason because they didn't request one. The rate of change is increasing. Let's think about the slopes. The slopes were at first very negative, and they were less negative as I went to the right. All right, so that is an increasing rate of change because the slopes are increasing. That's number 3. Right, now we're going to move on to number 4. Remember, number 4 is the one where we have to be very careful about simplifying our answer. I tried to zoom in on it some, but you've seen the box before, you've read it, you know what the deal is. Okay, we must simplify our answer. So functions g and h are given here, like an exponential and something with trig. All right, so solve and solve. That's going to be pretty typical for 4. It's going to be 2 times where you're going to solve, 2 times where you're going to rewrite, and then you're going to do something else totally crazy in part C. Okay, but really, if you just kind of like don't freak out at the beginning, it's going to be all right. You know, like just have faith that you're going to get weird numbers for these, but it's okay. G of x equals 27. So 3 to the 2x times 3 to the x plus 4 equals 27. G of x equals 27. Okay, we can do this. Okay, when we're multiplying two things with the same base and different exponents, we're going to add the exponents. It's going to equal 27. I think this can actually, we don't even need to take a log, really, because we know that 27 is a power of 3. So 3 to the 3x plus 4 equals 27, which is 3 cubed. So I think it'll be all right for us to equate the exponents. That didn't go well. Okay, here equal to that, and I get 3x plus 4 equals 3. 3x equals 1. Nope, that's going to be negative 1, and then x equals negative 1/3. Okay, then solve h of x equals 5. And I mean, like, I'm not even sure if they're, I really don't think they're grading really the work. But maybe I've seen one where they did grade the work kind of partially on the way on part C. So I don't know. This AP Precal thing, it's a little weird to me. For part 2, we want to know where h of x equals 5. So 2 tangent squared x subtract 1 is equal to 5. Okay, now I'm going to isolate the tangent, so I'm going to be adding 1 to both sides of this equation if that 5 ever like shows up. There it is. Okay, so 2 tangent squared x equals 6, and it looks like I can get about 10 seconds before it does that now. Divide both sides by 2. Okay, take the square root of both sides, so that's going to be tangent x equals plus or minus the square root of 3. And, okay, that's going to be kind of, you know, something that we have to solve. We have to know how to find that on the unit circle. Okay, and if we're unsure, you know, we see that square root of 3, so we know it's going to have to do with 30, 60, 90 triangles. That's one thing we should definitely know from AP Pre-Cal. So if we think, you know, maybe my hypothesis is pi over 3, because that's what it's going to be. Okay, I go up here, and I'm just going to think about, you know, the standard diagram we draw, where the hypotenuse is 1, and then the short leg is a half and the long leg is root 3 over 2. Yeah, that's going to work. Okay, so tangent x is equal to positive root 3 there. Would also equal positive root 3 down here. Okay, and then negative root 3 would be these 2 points also, so that's going to be x equaling pi over 3, 2 pi over 3, And they only asked in the interval 0 to 2 pi, so that would be 4 pi over 3 and also 5 pi over 3. And we don't need the 2 pi in because they only asked about the ones in the interval 0 to 2 pi. All right, so now part B. Let's just keep going. Part B here. J and K are given by these two things, right? J is a single logarithm with base 10. All right, so 2 log base 10, don't really need the 10 of x plus 3, minus log base 10 of x, minus log base 10 of 3. Okay, let's just take this one step at a time here. I'm going to deal with that 2. That can become an exponent, log of x plus 3 squared. And if you look at the actual rules, that you see in the box, you don't have to like square out a binomial. So minus the log of x minus the log of 3. Okay, now we're going to do log of x plus 3 squared over x. Okay, subtraction becomes a division on the inside of the log. And then I'm going to be subtracting log of 3. Okay, so that's going to be divided again, and so that's just going to go into the denominator. So x plus 3 squared divided by 3x. You could write it base 10 like that, but you don't need the base 10, it's implied. Okay, but the result should be of the form log base 10 of an expression, so yeah, maybe I'll just do what they say. All right, k of x involving secant and nothing else. Okay. We know k of x is equaling tangent squared x times cotangent x. Okay, well, why would they even do that? X are already reciprocals divided by cosecant x. All right, so I'm of a mind. I don't even think I need to use a Pythagorean identity for this one. Tangent x over 1 times tangent x over 1. Okay, that's my tangent squared. The cotangent is a 1 over tangent. Okay, and then cosecant in the denominator, I'll just leave that there for now. Okay, just deal with these tangents. Okay, now I have tangent x over cosecant. Maybe I should just write everything in terms of sine and cosine. And then sine over cosine is tangent, and then 1 over secant is sine over 1. Okay, I need more paper, I guess. Where even am I? Okay, so that's sine squared x divided by cosine. It said secant and nothing else. Okay, all right, sine squared x. I do need a Pythagorean identity, and just almost 2 hours into this video, I'm about to go nuts. I'm really tired of this practice exam, to be honest, but it's okay. It's good that we have one full practice exam video, on this channel, I think. So we know that sine squared theta plus cosine squared theta equals 1. So sine squared theta is going to equal 1 minus cosine squared theta. In our case, where I've got this sine squared x, I'm going to replace that with 1 minus cosine squared x, divide that all by cosine x. Okay, now I'm going to look at this as like 1 over cosine x, kind of distribute the 1 over cosine x to the 1, and the cosine squared x, oh my goodness, over cosine x. 1 over cosine is secant x minus, this is just 1 cosine x, but they wanted it in terms of secant only. I'm not very impressed with this type of problem here. I don't really see the benefit to your overall understanding of pre-calculus or later on calculus by being able to do this. But it's something we have to do for the AP exam, so it's something we learn how to do and we perform it and we get our credit and we'll move on with our lives. So now we're going to, lastly in part C, find where m of x equals 1 over 16, and that is going to bring this video to a nice close, hopefully just short of 2 hours. So 2 to the 5x plus 3 divided by 2 to the x minus 2 cubed equals 1 over 16. I think I should simplify what I've got going on the left-hand side of the equation first before even dealing with the 1 over 16. I think it's very tempting to cross-multiply, and we could do that, but I just don't. And you could even write 16 as 2 to the 4 and do it that way. I'm just going to go with the exponent properties. And I'm going to reorganize this. You can see that anymore, so I'm going to be just doing on an exponent property level 5x plus 3. Deal with that power of power. We're multiplying those exponents. Multiply the 3 over the x and the negative 2. And then if I'm dividing two things with the same base and different exponents, I'm subtracting the exponents. 5x minus 3x is 2x. 3 minus negative 6 is positive 9. Okay, 1 over 16 is 2 to the negative 4th power, because 16 is 2 to the 4th in the denominator. That would be 2 to the negative 4 power. Now I'm going to equate the exponents. 2x plus 9 equals negative 4. Subtract 9. Divide by 2, get negative 13 divided by 2. That's going to be all for this one. That's all for this video. I'm done. Thanks for watching.